Hello everybody, this is Shankar from SystemBaseLabs. Welcome back to the course From Models to Autonomous Enterprise Systems. Module 3, The Rise of Deep Learning Systems. Video 5 of 6, Class 17, GPU Acceleration, Big Data, and AI Scalability. Core theme, Why Compute Infrastructure Transformed AI Capabilities Globally. Now, in our previous session, we explored sequence models, RNNs, and language learning. We discussed how machines started understanding sequential information, memory flow, contextual relationships, and language structures, and that was a major breakthrough. But today, we are going into something equally important because intelligence alone was not enough. AI also needed scale, massive scale. Today, we are talking about GPU acceleration, big data, and AI scalability. Now, let me ask you something. Suppose you design an extremely powerful neural architecture, wonderful mathematics, excellent learning capability, beautiful intelligence model, but what happens if training that model takes 20 years? Then practically the system becomes useless. Now, this was one of the biggest bottlenecks in early deep learning systems. The ideas existed, neural architectures existed, but compute infrastructure was too weak. Think carefully about this. Deep learning systems perform enormous mathematical operation continuously. Matrix multiplications, tensor operations, gradient calculations, backpropagation cycles, millions, sometimes billions of parameter updates. And traditional CPUs struggled badly with this workload because CPUs were optimized for sequential processing, one task at a time. But deep learning required something very different, massive parallel computation. And this is where GPUs changed artificial intelligence forever. Graphics processing units. Now, originally, GPUs were designed for gaming and graphics rendering, video acceleration, visual effects. But researchers discovered something revolutionary. GPU architectures were extremely effective at parallel mathematical computation. Very important insight. Now pause there for a moment. Think carefully about what just happened architecturally. Gaming hardware unexpectedly became one of the foundations of modern AI infrastructure that changed computing history. Now, instead of processing calculations sequentially, GPUs could process thousands of operations simultaneously. And suddenly, deep learning training accelerated dramatically. Models that once required months could now train in days, sometimes hours, and this triggered an explosion in AI capability globally. Now, another major factor also emerged during this period. Big data, very important. Deep learning systems are data-hungry systems. The larger the model, the more data it generally requires. Now, at the same time, the internet exploded globally. Social media platforms expanded, mobile devices generated enormous behavioral data. Sensors produced continuous streams of operational information. Enterprises collected massive data sets, and suddenly AI systems had access to unprecedented amounts of information. Now combine massive data, GPU acceleration, cloud infrastructure, and scalable neural architectures, and modern AI became possible. This convergence changed everything. Now, from an enterprise perspective, this transformed operational intelligence globally. Computer vision improved dramatically. Speech systems became commercially scalable. Natural language processing accelerated rapidly. Recommendation systems became extraordinarily powerful. Fraud systems became more adaptive. Autonomous systems became increasingly realistic. And enterprises realized something critical. AI was no longer just software. AI had become infrastructure. Very important architectural transition. Now another major concept emerged here. Scalability. AI infrastructure itself became a strategic enterprise capability. Because once organizations started training larger models, everything changed. More parameters, more data sets, more compute clusters, more distributed systems, more energy consumption. And this eventually led to AI supercomputing and hyperscale intelligence architecture. Now, another important insight. Modern AI breakthroughs were not created by algorithms alone. They emerged from the convergence of math, architecture, infrastructure, and data. Because many people mistakenly think AI evolved only because models became smarter. No, AI also evolved because infrastructure became powerful enough. Now, of course, this introduced major enterprise challenges to GPU shortages, training costs, massive energy requirements, cloud dependency, infrastructure centralization, and eventually AI compute itself became geopolitical infrastructure, very important modern reality. Now, another major architectural transformation happened. AI systems started shifting from research scale intelligence to industrial scale intelligence. And that shift opened the door toward foundation models, large language models, generative AI, and multimodal systems. Deep learning succeeded not only because machines learned better, it succeeded because humanity built the infrastructure to scale intelligence globally. Now, in our next session, we continue Module 3, Video 6 of 6, Class 18, The Transformer Revolution, where we will explore how attention mechanisms and context windows transform the future of AI forever. Thank you, everybody. This is Shankar from SystemBaseLabs. Good luck and goodbye.